graded Math 6-7 students. We are working in Module 8, and this is Lesson 4. Okay. Module 8, Lesson 4 is called Addition and Subtraction of Rational Numbers. Our goal for today. Today we are going to practice adding and subtracting rational numbers. The question that I want you to be thinking about is, what is a property that you could use to help make adding or subtracting rational numbers easier? And so we're going to be talking about all the rules that we've learned in the last couple of lessons, and we need to remember them so that they can help us. All right, first thing that we want to do is things to remember. Are these two math expressions that you see the same? Your job is to prove it. So we're going to take a look at what we are working on and see if we can decide if those two are the same. And so we're going to use the rules and the information that we've been working on to help us figure that out. Okay? And so I would like to take a look at this. First thing that I want to do is draw it. Okay? I am not, however, going to use the chips because I don't want halves. So I'm going to use the number line. And so this question is saying, are these two expressions the same? And so we always start on 0. So we go 1, 2, 3, 4, and I draw a vector to 4. And then it says that I am supposed to take away 5 1/2 positives. Okay, well I can do that. So I'm going to take away 5 1/2. So there's 1, 2, 3, 4. 5 is here, and then half would be in the middle of that. And so this is -1, so this one right here is -1 1/2. So my answer to this one that I got was -1 1/2, okay, according to the number line. So now this one over here is telling me that I have 4, and I'm adding negatives on, okay? So I go, here's 0, and I go 1, 2, 3, 4. Here's 4 on my number line. And so I'm taking a vector up to 4. But it says I'm adding negatives. Well, I don't know if you can add negatives. So since we can't, that negative is telling me I need to go the other way with my arrow. And so I need to go to the left 5 1/2. So I'm going to go 1, 2, 3, 4, 5, and half of that. And where I stop is at -1 1/2. So as you can see, we just proved that these two are the same. Okay? And then, if you remember what we've been working on, we learned that when you have a subtraction problem, one of the rules that we learned that we can do is you take the subtraction sign and replace it with an addition sign, but then you have to make this number its opposite. So what is the opposite of positive 5 1/2? The opposite is -5 1/2. So we have 4 minus 5 1/2 is exactly the same as 4 plus a -5 1/2. Now look at these. 4 minus 5 1/2 is the exact same as 4 plus a -5 1/2. So we should have known that. That was trying to be trick questions. Okay, it was to prove something. So we just proved our knowledge from our previous lessons. So good job on that. All right, so now I want you to try something else. Let's try something else. It says we have a rational number 4. We have the rational number 5 1/2 equals the sum -1 1/2, which we already proved over there. So there's this thing that they want us to be aware of. I don't know how much you're going to use it, but it is nice to know, so I'm presenting it to you. They say that the opposite of a sum, this is the sum. So if the sum is -1 1/2, what is its opposite? Its opposite of the sum, well, the opposite of this sum would be 1 1/2. So it's saying the opposite of the sum is, which means equals in math, the sum of its opposites. So what that means is you're going to have to take the opposite of this, right? So 1 1/2 equals, what is the opposite of 4? -4, plus, what is the opposite of -5 1/2? 5 and a half. And so now, is this sentence true? Well, let's try it. You draw your number line, right? And this time it says we're going down to 4 and a half. So here's 0, 1, 2, 3, 4. Actually, just to 4. I'm sorry. So this would be -4, like it says right there. Then it says add 5 and a half to it. Okay. So I have a vector going to -4. I drew my graph incorrectly. I'm sorry. And I'm supposed to add 5 and a half. So I'm going to go 1, 2, 3, 4, 5 and a half. Where does that stop? It stops at 1 and a half. So that's a true statement. So read it with me. The opposite of a sum is the sum of its opposites. Okay? So look down here. The opposite of the sum, so that's -1 and a half. That's the opposite of it is 1 and a half. Is, which means equals, the sum of its opposites. The opposite of 4 is -4. The opposite of -5 and a half is 5 and a half. So some reason for learning this or knowing that is that sometimes you're going to get some really hard, yucky numbers. And so you need to remember that if you take the opposite of the sum, it will give you the answer to the opposite of the add-ins being added or the rational numbers being added. Okay? So now let's look at this. It says using the opposite of the sum is the sum of its opposites can make adding and subtracting rational numbers easier. And that's what I was trying to say, is we're going to get some complicated numbers, and sometimes we just need to have a different tool to help us. And that's what this is a different tool to help us. Sometimes you'll use it, sometimes you won't. It just depends on what they are. All right, so now let's look at this and see if I can thoroughly confuse you. I don't think you got confused with that, but we'll keep working. All right, another way says 7 plus a -9 or -9 plus 7. Which problem looks easier? So this, another way, is a personal preference. Which way do you like to see it? First of all, I need to highlight that we are adding. And since we are adding, I want you to think about something. When you add, order does not matter. There is a property that tells us that. Hopefully you can remember that property. So 7 plus a -9 or -9 plus 7 have the exact same answer. What do you think? Well, let's try it and prove it. So this one I'm going to use chips. So on this side I have 7 positive chips. 1, 2, 3, 4, 5, 6, 7. And they're all positive. So 7 positive chips. Then I'm adding 9 negative chips. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all negatives. Okay? And then we remember the rule that a positive and a negative make a 0 pair. 0 pair, 0 pair, 0 pair, 0 pair, 0 pair, 0 pair. What am I left with? 2 negative chips. Okay? Now let's do this side, and this time I'm going to use a number line. So here's our number line, right? And here's 0, and it says I have -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is -9 right here. So I start at 0, always draw a vector to -9, and this time it says I'm adding 7 positives. So let's do it. So start at -9 and add 7. So 1, 2, 3, 4, 5, 6, 7. I get to stop right here. So what number is that? That number is -2. Now look, -2 equals -2. So we just proved that these are the exact same problems. So 7 plus a -9 is exactly the same as -9 plus 7. Now, why am I showing you this? Because as long as you're adding, you can use the commutative property to make the problem easier. We're always looking for ways to make them easier because changing the order of the numbers does not change the answer, and we just proved that. Okay? So now I want you to practice these 3 problems. Okay? You can try it with the opposite of the sum, so that would be fun. If we figure out this one, we have 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8 negatives, right? plus 4 positives, 1, 2, 3, 4 positives. These are all zero pairs, 0, 0, 0. So my answer to this is 4 negatives. So if we remember the opposite of the sum, then we should be able to say, well, the opposite of -4 is 4 equals, and then remember we have to do the opposite of each of these. So what is the opposite of 4? -4. What is the opposite of 8? Oh, excuse me, what is the opposite of -8? 8. So I went too fast. And now let's draw this. So it says that we have 8 positives this time. Okay, 8 positives this time because of that one right there. Plus 4 negatives, 1, 2, 3, 4. 0 pair, 0 pair, 0 pair, 0 pair. And what is the answer on this one? 4 positives. So we just proved that that is true with using the opposites. So that's all I want you to do with the opposite of the sum. These other two problems, I want you to pick any way that you want. You could use number lines, you could use chips, you could use rearranging with the commutative property. As long as you're adding, you could rearrange them if that helps you. I want you to find the answers for these two problems, however you love, okay? All right, so let's go back to our goal for today. Our goal for today was, today we are going to practice adding and subtracting rational numbers. And the question that I want you to think about is, what property could you use that would make adding or subtracting rational numbers easier? And I think you know the answer to that. It starts with a C. All right, kiddos, that's all I have for you today. I'll talk to you soon. Bye.